China has consistently demonstrated leadership in transforming futuristic concepts into functional reality. The country's recent innovations extend beyond incremental improvements, and they represent a fundamental reimagining of transportation systems themselves. From elevated autonomous rail systems to amphibious electric vehicles and vertical takeoff aircraft, these developments provide tangible evidence that advanced mobility solutions are transitioning from theoretical designs to operational infrastructure. Let's examine how engineering innovation is converting conceptual transportation models into measurable reality. BYD Yangwang U8 Amphibious SUV Engineering. The BYD Yangwang U8 represents a significant achievement in automotive multi-environment capability, the first production vehicle designed to operate both on land and temporarily on water while maintaining luxury SUV characteristics. The vehicle's intelligent hydraulic suspension system enables vertical adjustment of up to 150 mm, allowing dynamic adaptation to challenging terrain or flooded conditions. Priced at approximately $150,000, the U8 demonstrates China's capacity to integrate advanced engineering into premium market positioning. One notable feature is the tank turn capability, the ability to rotate 360 degrees in place through independent wheel control. However, the most scientifically interesting aspect is the emergency flotation system. When integrated flood sensors detect water ingress danger, the system automatically initiates a protective sequence. The engine shuts down, windows seal hermetically, climate control maintains cabin comfort, and the sunroof opens slightly to equilibrate air pressure. In flotation mode, the U8 can remain buoyant for up to 30 minutes and propel itself at approximately 3 km per hour. This allows occupants to navigate away from flooded areas safely. The vehicle achieves IP68 waterproofing certification and can wade through water up to 1,000 mm deep in standard configuration or 1,400 mm when equipped with a snorkel in the Off-Road Master Edition. Post-flotation operation requires comprehensive suspension system inspection before resuming normal driving. Dr. Wei Chen, automotive engineering professor at Tsinghua University, explains that the flotation capability relies on precise buoyancy calculations. The vehicle's sealed cabin and strategic weight distribution create sufficient displacement to support the total mass. The U8's powertrain combines 4 electric motors, delivering a combined 1,180 horsepower with a 2.0-liter turbocharged range extender engine, providing 621 miles of total range. This extended range electric vehicle architecture eliminates range anxiety while maintaining zero-emission capability for urban driving. By integrating innovation, safety protocols, and environmental adaptability, the BYD Yangwang U8 expands the operational envelope of traditional SUVs. SkyTrain, elevated autonomous rail systems. China has introduced the world's first fully autonomous aerial monorail system. This elevated rail network operates above ground level, eliminating surface traffic interference. Extending across 10.5 kilometers in Wuhan's Optics Valley, the SkyTrain traverses an elevated guideway at speeds up to 60 kilometers per hour, with capacity for approximately 220 passengers. The suspended monorail connects scenic areas including Jufeng National Forest Park and Longquan Mountain Archaeological Park, serving both commuter and tourism functions. What makes this particularly noteworthy is the construction timeline. The entire system was completed in just 7 months, comparable to traditional railway construction periods, while delivering greater passenger capacity and reduced accident risk. The system opened to the public in September 2023, with plans to extend to 26.7 kilometers and 16 stations in the second phase. The true innovation lies in transforming urban mobility patterns. By elevating rail infrastructure above city streets, the system completely bypasses surface traffic congestion. The transparent glass floor allows passengers to view the city beneath them, creating a unique travel experience. Dr. Liu Xiaoming, urban transportation researcher at Beijing Jiaotong University, offers perspective. Elevated autonomous rail represents optimal utilization of 3-dimensional urban space. Vertical separation eliminates competition for ground area while maintaining accessibility through strategically positioned stations. The construction costs remain comparable to conventional railways at approximately one-fifth the cost of underground subway systems, making it an economically viable solution for expanding urban transit networks. The XPeng Voyager X2 provides empirical evidence that personal flight technology has progressed from concept to a functional prototype. This vehicle features vertical takeoff and landing capability, enabling a seamless transition between ground and aerial operation. With an empty weight of 560 kilograms and a maximum takeoff weight of 760 kilograms, the X2 uses 8 synchronized rotors built on a full carbon fiber structure. The dimensions measure 4.97 meters in length when the propeller arms are extended, with a propeller diameter of approximately 1.83 meters. The cabin holds 2 occupants and provides comprehensive situational awareness during flight. The X2 reaches maximum speeds of 130 km per hour, and it can maintain flight for up to 35 minutes at altitudes around 1,000 meters. The aircraft includes advanced safety features, including radar ranging, sensory obstacle avoidance, an emergency ballistic parachute, and omnidirectional cameras for complete environmental awareness. Significantly, it supports both manual and autonomous flight modes, with autonomous flight path planning capabilities. Dr. Zhang Peng, aerospace engineer, explains that vertical takeoff and landing personal aircraft must solve multiple engineering problems simultaneously: a sufficient power-to-weight ratio for vertical lift, stability during transition, intuitive controls, and adequate safety redundancy. The X2 addresses these through distributed electric propulsion and advanced flight control algorithms. The larger X3 prototype, weighing approximately 1,936 kilograms, represents XPeng's development toward road-capable flying vehicles. The X3 features fold-away rotor arms that allow it to function as a conventional automobile on roads before extending rotors for flight. Though it remains in testing phases, successful maiden flights demonstrate the technical feasibility of true flying cars. XPeng has established pricing for the X2 in the range of $126,000 to $236,000, with serial production and deliveries expected to begin in 2024. The company has already conducted public demonstration flights in Dubai and is working with aviation authorities for certification. Lazareth LMV 496 Hybrid Jet-Powered Motorcycle. The Lazareth LMV 496, created by French engineer Ludovic Lazareth, is the world's first hybrid electric jet-powered motorcycle. On roads, it functions like a premium electric superbike, delivering approximately 100 kilometers of range. When flight mode activates, 4 jet turbines integrated into the wheel hubs tilt downward, releasing powerful thrust. These kerosene-fueled turbines generate approximately 1,300 horsepower, sufficient to maintain the LMV 496 airborne for up to 10 minutes. With a price point around $500,000, it is crafted for specialists who seek the convergence of speed, technology, and exclusivity. Dr. Antoine Moreau, propulsion systems specialist, analyzes the LMV 496 solves a fundamental challenge, generating sufficient thrust-to-weight ratio for vertical lift using compact propulsion systems. The jet turbine configuration provides the necessary power density. Xiaomi Ninebot Mini Self-Balancing Personal Transporter. The Xiaomi Ninebot Mini represents compact personal transportation that maintains autonomous balance through gyroscope systems and self-balancing algorithms. Weighing only 12 kilograms, it can support loads up to 85 kilograms, reach speeds of 15 kilometers per hour, and travel more than 22 kilometers on a single charge. Riders control it entirely through body movement. Leaning forward initiates motion, and leaning back stops movement. New operators require several days of practice. Dr. Yuki Tanaka, robotics researcher, explains that self-balancing systems use inverted pendulum control theory. Microprocessors calculate corrective motor responses hundreds of times per second, maintaining dynamic stability. EHang 216S Autonomous Air Taxi. The EHang 266S is a fully electric autonomous air taxi designed for short to medium distance flights. Powered by 16 electric rotors arranged in 8 symmetrical pairs, it provides stable vertical takeoff and landing. The cabin seats 2 passengers and achieves maximum speeds of 150 km per hour, operating at altitudes up to 3,000 meters. What distinguishes the EHang 266S is its fully autonomous flight system powered by artificial intelligence. The system manages every phase, takeoff, navigation, and landing, without requiring pilot intervention. Intelligent safety protocols incorporate redundant power distribution systems that ensure safe landing even if one rotor fails. The aircraft utilizes 38 sensors, including 3 LiDAR units, 13 cameras, 12 ultrasonic radars, and 5mm wave radars, providing comprehensive environmental awareness. The NVIDIA Drive Orin system on a chip processes sensor data with 508 TOPS of computational power, enabling real-time decision-making. Dr. Sarah Martinez, urban air mobility researcher at NASA, provides context. She says, "The EHang 266S demonstrates that autonomous electric VTOL technology has matured sufficiently for controlled urban deployment. Several cities in China have already approved test routes for passenger-carrying flights." Aurrigo Autonomous Transportation Solutions. Aurrigo's self-driving vehicles maximize efficiency and safety across airports, urban centers, and logistics facilities. These electric autonomous pods utilize LiDAR sensors, radar systems, and 360-degree cameras, combined with AI navigation capable of centimeter-level accuracy. Models like the Aurrigo Auto Shuttle accommodate up to 10 passengers, reach speeds of 40 to 50 km per hour, and travel 120 to 190 km per charge. The vehicles perform reliably across various weather conditions, with fully electronic drive-by-wire and brake-by-wire systems ensuring stable operation. Dr. James Wilson, Autonomous Systems Engineer at MYT, notes that Aurrigo's approach demonstrates that deployment challenges are solvable through comprehensive sensor fusion and intelligent software architecture. He says the platform integrates easily with existing infrastructure, enabling rapid deployment. Honda MotoCompacto Urban Electric Scooter. Honda's MotoCompacto addresses short-range urban travel, reaching maximum speeds of 24 km per hour with a riding range of approximately 19 km. Weighing only 18.7 kilograms, it is exceptionally portable. Battery recharging requires approximately 3.5 hours, and riders can select between 2 power modes, standard and a beginner mode that limits speed to 16 km per hour. With a retail price around $1,000, it delivers a practical, environmentally friendly solution for navigating crowded urban environments. The design pays homage to Honda's vintage gas-powered MotoCompacto from the 1980s, while incorporating modern electric technology. Dr. Emily Chen, sustainable transportation researcher, provides perspective. Lightweight electric scooters fill the last-mile transportation gap effectively. They are affordable, zero-emission, and require minimal infrastructure. NIO ET9 Intelligent Luxury Sedan. The NIO ET9's most impressive capability is autonomously shaking accumulated snow off the roof through advanced hydraulic suspension that systematically tilts the vehicle body side to side. The Skyride Intelligent Chassis System, developed in collaboration with US-based ClearMotion, incorporates 4 dedicated hydraulic pumps independently controlling each wheel. Unveiled in December 2024, the ET9's dual-motor, all-wheel drive system delivers 697 horsepower and 700 Nm of torque, accelerating from 0 to 100 km per hour in 4.8 seconds, with a top speed of 200 km per hour. The powertrain utilizes China's first mass-produced 900-volt electrical architecture, enabling exceptional charging performance. The 120 kWh battery pack provides an estimated driving range around 720 km under WLTP testing. High-speed DC charging at up to 600 kilowatts can restore the battery from 30% to 80% in just 18 minutes. with the ability to add 255 kilometers of range in 5 minutes. The ET9 measures 5,325 millimeters in length, with a wheelbase of 3,250 millimeters, positioning it as a full-size luxury sedan competing with the Mercedes-Benz EQS, BMW i7, and Porsche Panamera. The 4-seat configuration prioritizes executive comfort, with rear seats featuring 45-degree recline capability. With a starting price of approximately $109,000 in China or $91,200 with battery subscription, the NEO ET9 demonstrates modern automotive intelligence and refined engineering. The first edition, limited to 999 units, sold out within 12 hours of becoming available. Dr. Li Wei, electric vehicle systems engineer, explains, "Active hydraulic suspension uses electronically controlled valves to adjust fluid pressure independently. This enables dynamic body motion control for functional purposes like snow removal or enhanced cornering stability. It represents the evolution from passive mechanical systems to active mechatronic systems." The ET9 also incorporates rear-wheel steering with a maximum angle of 8.3 degrees, reducing the turning diameter to just 10.9 meters despite its substantial size. The steer-by-wire technology eliminates mechanical connections between the steering wheel and wheels, allowing for programmable steering responses. Understanding the transportation transformation. From flying cars to autonomous electric trains, we are entering an era where innovation fundamentally reshapes human mobility capabilities. Vehicles that once seemed purely speculative are now operational, including cars that autonomously remove snow, robots that navigate independently, and electric pods gliding through urban environments. This new wave emphasizes electric propulsion and autonomous control. These technologies share common characteristics. They use electric propulsion for reduced emissions, autonomous operation for enhanced safety, multimodal capability that expands operational flexibility, and intelligent systems that adapt to environmental conditions. The convergence of these elements represents more than incremental progress. It signals a fundamental change in how people conceptualize and experience movement through physical space. The economic implications are substantial. China's transportation technology sector has attracted hundreds of billions in investment, creating entirely new industries and employment categories. Engineers, software developers, battery chemists, and urban planners are collaborating to solve challenges that did not exist a decade ago. This economic shift is creating new career paths and new markets. Dr. Martinez summarizes that we are witnessing convergence of electric powertrains, autonomous navigation, advanced materials, artificial intelligence, and three-dimensional mobility. Together, they are creating entirely new transportation paradigms that were not possible even a decade ago. The speed and scale of deployment are particularly significant. Technologies that typically require decades to mature are reaching commercial viability in just years. The regulatory environment is evolving rapidly to accommodate these innovations. Aviation authorities are establishing new categories for urban air mobility vehicles, and transportation departments are creating frameworks for autonomous ground vehicles. This regulatory agility, particularly evident in China, accelerates the path from prototype to production. The transportation revolution is not coming. It is already here, taking tangible form on roads, rails, and increasingly in the airspace around us. As these technologies mature and costs decrease, they promise to democratize access to advanced mobility, transforming not just how we move, but how we design cities, conduct business, and organize society itself.